Close your eyes. Imagine a planet, blue oceans stretching to the horizon, clouds drifting lazily across the sky, maybe some continents, volcanic islands, the occasional thunderstorm. Temperature, a comfortable 70 degrees Fahrenheit. Perfect beach weather. Now imagine I told you this planet had shallow seas, teeming with possibilities, rivers carving valleys, rain falling gently on pristine landscapes, a thick atmosphere protecting it all, like a warm blanket around a newborn world. This was Venus, 3 billion years ago. Now Venus is what happens when a planet decides to commit elaborate suicide and takes 700 million years to do it. Today, Venus is 900 degrees Fahrenheit at the surface, hot enough to melt lead, atmospheric pressure 92 times Earth's, like being 3,000 feet underwater, raining sulfuric acid that evaporates before hitting the ground, rotating backwards, because why not? Day longer than its year, because physics gave up. Earth and Venus are twins. Same size, same mass, same basic composition, formed in the same stellar neighborhood from the same materials. For the first billion years, they were nearly identical, two blue marbles orbiting a young sun. Then Venus chose a different path, a path that led to the most spectacular planetary catastrophe in our solar system. A transformation so complete, so horrifying, that if it happened to Earth, every single living thing would be dead within decades. And here's the part that should keep you up at night. Venus didn't gradually become hell. It happened fast. Cosmically speaking, Venus went from paradise to purgatory in the time it took life on Earth to figure out photosynthesis. What happened to Venus isn't just a story about a planet that got too hot. It's a warning, a 4.5 billion-year-old cautionary tale floating in our sky, visible to the naked eye, screaming at us in frequencies we're only now learning to hear. Because what happened to Venus could happen to Earth. In fact, it will happen to Earth. The only question is when, and whether we'll be the ones to pull the trigger. Welcome to the story of how Earth's twin became the solar system's most successful serial killer, murdering its oceans, its atmosphere, and possibly its life, then keeping the corpses around as trophies. All right, my fellow inhabitants of the planet that didn't choose violence, welcome to minutes of existential climate anxiety disguised as planetary science. Get comfortable, but not too comfortable, because comfort is what Earth has that Venus lost, and we need to talk about that. But first, let's properly introduce you to Earth's evil twin. And when I say twin, I mean it. The similarities are unsettling. The twin statistics. Size. Venus diameter is 12,104 kilometers. Earth diameter is 12,742 kilometers. Difference? 5%. Mass. Venus is 82% of Earth's mass. Earth is the standard by which we judge other planets. So similar that if you weighed 150 pounds on Earth, you'd weigh 135 on Venus before being crushed and incinerated. Density. Venus is 5.24 grams per centimeter cubed. Earth is 5.52 grams per centimeter cubed. Both have iron cores, rocky mantles, thin crusts. Basically the same layer cake, different frosting. Look at those numbers. We're practically identical. It's like looking in a mirror that shows you after 700 million years of meth. Location, location, location. Venus orbits at 0.72 AU from the Sun. Earth at 1 AU. That's just 28% closer to our star. You'd think that wouldn't make much difference, right? Wrong. Dead wrong. Literally dead. That 28% difference is the difference between having dolphins and having atmospheric pressure that could crush a nuclear submarine like a beer can. Venus receives about 1.9 times more solar energy than Earth. That's not even double. Los Angeles gets more than 1.9 times the sunshine of Seattle, and last I checked, Seattle hasn't turned into a sulfuric acid hellscape. Yet. The backwards planet. Here's where Venus starts getting weird. It rotates backwards, what we call retrograde rotation. If you stood on Venus, you can't, you'd die.
and somehow saw the sun through the clouds, you couldn't, they're opaque, it would rise in the west and set in the east. But here's the really messed up part. A day on Venus, 243 Earth days, is longer than a year on Venus, 225 Earth days. Venus takes longer to spin once than to orbit the sun. Imagine if Earth did that. You'd go to bed in January, wake up in August, have lunch in December of the next year. Your workday would last 8 months. Your weekend would last 4 months. Actually, that part sounds kind of nice. Humanity's toxic relationship with Venus. Every ancient civilization that could see the sky was obsessed with Venus. The Babylonians called it Ishtar, goddess of love and war, how prophetic. The Greeks named it Aphrodite, beauty hiding danger. The Romans, Venus, goddess of love, ironic for a planet that kills everything. The Maya, Kukulkan, the feathered serpent. At least they sensed the danger. The Chinese, Taibai, the great white one, before they knew how not white it was. For thousands of years, Venus was the morning star and the evening star, the brightest natural object in our sky after the sun and moon. Humanity literally used it for navigation, based calendars on it, wrote poetry about it. We were basically stalking our future killer, writing love songs about the planet that would murder us if we got too close. It's the astronomical equivalent of swiping right on someone whose profile pic is them holding a knife. The shocking reveal, 1960s edition. Until the 1960s, scientists genuinely thought Venus might be a tropical paradise, a global ocean world, a swamp planet with dinosaurs, Earth's backup plan. Then we sent the first probes. Mariner 2 in 1962 took Venus's temperature, 800 degrees Fahrenheit. The scientific community's response was basically, wait, what? Check that again. That can't be right. Oh God, it is right. Oh no. Oh no. The Soviet Venera probes kept dying. Venera 3 crashed. Venera 4 died during descent. Venera 5 and 6 were crushed by the atmosphere. Venera 7 barely survived landing, transmitted for 23 minutes before Venus killed it. Venus was literally murdering our space probes, and we kept sending more like some cosmic horror movie where the teenagers keep going into the basement. What we know now, the full horror. After dozens of missions, here's Venus's current rap sheet. Surface temperature, 864 degrees Fahrenheit. Hot enough to melt lead, zinc, and your hopes and dreams. Hotter than Mercury despite being farther from the sun. No variation between day and night, the heat has nowhere to go. Atmospheric pressure, 92 bars, equivalent to being 3,000 feet underwater. Would crush a human in seconds. Makes Earth's worst hurricane feel like a gentle breeze. Atmospheric composition, 96.5% carbon dioxide. Earth has 0.04%. 3.5% nitrogen, traces of sulfur dioxide, argon, water vapor, clouds of concentrated sulfuric acid. But here's the thing that should really terrify you. We have evidence that Venus used to have oceans, rivers, rain, possibly even plate tectonics and a magnetic field. Venus was Earth before Earth figured out how to be Earth. And then it all went wrong. Catastrophically, irreversibly wrong.
Let me take you back 4 billion years. The solar system is young and optimistic. The late heavy bombardment is winding down. The planets are settling into their orbits. And Venus? Venus is gorgeous. The evidence for ancient oceans. How do we know Venus had oceans? We count what's missing. The deuterium smoking gun. Deuterium is heavy hydrogen. Hydrogen with an extra neutron. On Earth, for every 6,420 normal hydrogen atoms in water, there's one deuterium atom. On Venus, for every 100 normal hydrogen atoms, there's one deuterium atom. That's 100 times more deuterium concentration than Earth. Why? Because when Venus's oceans evaporated, the lighter hydrogen escaped to space faster than heavy deuterium. It's like finding salt stains in a desert and realizing it used to be an ocean. Based on the deuterium ratio, scientists calculate Venus had enough water to cover its entire surface to a depth of, conservative estimate, 10 meters, 30 feet, likely estimate, 100 meters, 300 feet, optimistic estimate, 3 kilometers, or 2 miles. Venus had oceans, real, wet, splashing oceans. You could have gone surfing on Venus. Well, you couldn't because you didn't exist yet, and if you did, you'd be a single-celled organism, but theoretically, something could have surfed those waves. The granite problem. Here's something that breaks geologists' brains. Venus has granite. Specifically, the Tessera Highlands show spectroscopic evidence of granite-like rocks. Why is this huge? Granite forms when basaltic rock melts in the presence of water. The melt rises and cools slowly. Large crystals form. No water equals no granite. Finding granite on Venus is like finding a fish fossil in the Sahara. It shouldn't be there unless the conditions were completely different in the past. Venus is literally made of rocks that scream, "I used to be wet." The first billion years, twin paradise. From 4.5 to 3.5 billion years ago, Venus and Earth were nearly identical. Similar atmospheres, mostly nitrogen, some CO2 but not insane amounts, water vapor, trace gases. Similar temperatures. Earth, 70 to 90 degrees Fahrenheit average, Venus, 80 to 100 degrees Fahrenheit average, estimated. Both had ice caps possibly. Both had weather systems, similar geology, active volcanoes, possible plate tectonics, weathering and erosion, mountain building. For a billion years, Venus and Earth were like twin sisters who dressed alike, had the same hobbies, finished each other's sentences. If aliens had visited 4 billion years ago, they would have struggled to pick which planet would become the hellscape. The habitable Venus hypothesis. NASA's climate models suggest ancient Venus could have been habitable for up to 3 billion years, not just not deadly, but actually pleasant. The modeled paradise, shallow seas covering 60% of the surface, an average temperature of 59 degrees Fahrenheit, 15 degrees Celsius, Earth-like clouds and rain, stable climate lasting billions of years, potentially habitable until 700 million years ago. Think about that. Venus might have been habitable for 3 billion years, complex life, maybe even intelligent life, and then Venus killed it all. The search for Venusian fossils. If Venus had life, could evidence survive? The surface has been completely resurfaced by volcanism, but where fossils might hide? Tessera Highlands, oldest terrain, subsurface layers protected from the heat, chemical biosignatures in minerals, isotope ratios in atmospheric gases, possibly in the cooler cloud layers. Of course, finding these fossils means landing on Venus, surviving more than 2 hours, the current record, drilling through volcanic rock while being crushed and melted, and somehow getting samples back to Earth. Easy peasy. The beginning of the end. Around 3 billion years ago, something started to change. The change was subtle at first. Slightly higher temperatures, more water vapor in the atmosphere, increased volcanic activity, and changing atmospheric chemistry. Venus was developing a fever. Not a dramatic spike, just a degree here, a degree there. The kind of change that takes millions of years to notice. The kind of change that seems reversible until suddenly it's not. What triggered it? We have theories. The sun got brighter. It's 30% brighter now than 4 billion years ago. Massive volcanic eruptions, loss of magnetic field, slowing rotation. All of the above in a perfect storm of planetary destruction. The point of no return. Here's the terrifying truth about planetary climates. They have tipping points. Push them too far, and they don't gradually change, they flip, like a light switch, like falling off a cliff, like Venus. The Venusian tipping point, temperature reaches about 100 degrees Fahrenheit globally, water vapor increases in atmosphere, Water vapor is a greenhouse gas. More heat trapped, more evaporation, more water vapor, more heat. Runaway greenhouse effect initiated. Once this started, Venus had maybe 100 million years before complete catastrophe. That sounds like a long time, but geologically, that's a heartbeat. That's Earth's history since the dinosaurs. That's nothing.
Imagine you're an alien observer watching Venus 2 billion years ago. You've been monitoring this nice blue planet with oceans and clouds. You go away for just 700 million years, maybe to get space coffee or whatever aliens do, and when you come back, the planet is dead. Not dying, dead, murdered by its own atmosphere. The runaway greenhouse effect. Climate change on steroids. Let me explain runaway greenhouse effect in terms that will haunt your dreams. Step 1. The initial warming. Sun gets slightly brighter, Venus gets slightly warmer, some polar ice melts, if it had any, darker ocean absorbs more heat. Step 2. The water vapor feedback. Warmer temperatures means more evaporation. Water vapor is a greenhouse gas, worse than CO2. More water vapor means more heat trapped. More heat means more evaporation. Step 3. The cloud failure. Clouds initially reflect sunlight. Good. But water vapor overwhelms cloud formation. Atmosphere becomes saturated. Clouds stop forming properly. Lost cloud albedo means more heating. This is where Earth climate change deniers would say, but warming is natural. Yes, and so is dying. Doesn't mean you want to speed it up. The hydrogen escape. Venus bleeds out. Here's where Venus's death becomes irreversible. The atmospheric bleed. Water vapor rises to upper atmosphere. UV radiation from the sun breaks H2O into H and O. Hydrogen is light, escapes to space. Oxygen reacts with surface rocks or carbon. Water is permanently destroyed. The numbers? Venus lost roughly 10 to the 20 kilograms of water. That's about 100 times Earth's Black Sea. Lost at a rate of millions of tons per year. Took 600 million years to lose it all. Venus didn't just lose its oceans, it lost the ability to ever have oceans again. The hydrogen is gone, floated away into space. Venus bled out its water molecule by molecule, and there's no cosmic transfusion that can bring it back. The carbon catastrophe. On Earth, CO2 gets locked away through dissolving in oceans, forming carbonate rocks, being absorbed by life, weathering of silicate rocks. On Venus, once the oceans evaporated, no water to dissolve CO2, no liquid water for carbonate formation, no life to absorb it, if there ever was any, no weathering without water. All the CO2 that should be locked in rocks, it's in the atmosphere. Venus's atmosphere contains roughly the same amount of CO2 as Earth, but Earth's is locked in limestone and life. Venus's is all gas, baby. The pressure cooker effect. As Venus heated up, the vicious cycle. Heat releases CO2 from rocks, CO2 adds to greenhouse effect. More heat releases more CO2. Pressure increases, higher pressure holds more heat, surface becomes literal pressure cooker. Final atmospheric pressure, 92 bars. Earth's atmosphere weighs about 5.5 quadrillion tons. Venus's atmosphere weighs 93 times that. It's not an atmosphere anymore, it's an ocean of gas. An ocean that crushes, an ocean that burns, an ocean you can't swim in because you'd be dead. The volcanic renaissance, resurfacing hell. About 700 million years ago, Venus did something spectacular and horrifying. It resurfaced itself, the entire planet, all at once. The global resurfacing event, possibly triggered by internal heat buildup, no plate tectonics to release pressure gradually, heat builds until catastrophic release. Global volcanic eruption lasting millions of years. Entire surface covered in lava.
Imagine every volcano on Earth erupting simultaneously. Now imagine that continuing for a million years. Now, imagine the lava floods being miles deep. That's Venus's idea of redecorating. The evidence? Only 1,000 craters on the entire planet. All craters roughly the same age. No old terrain anywhere. Volcanic features everywhere. Surface age? 300 to 700 million years. Venus literally gave itself a planetary facial with lava. Extreme makeover, hellscape edition. The ultimate resurfacing treatment. Side effects might include complete sterilization, atmospheric toxicity, and death of all living things. The magnetic field mystery. Earth has a magnetic field. It protects us from solar wind, keeps our atmosphere from being stripped away. Venus? No magnetic field. Why Venus lost its magnetic shield? Possibly never had one, but probably did. Core cooled due to lack of plate tectonics. No convection in core. No magnetic dynamo. Without protection, solar wind strips the atmosphere, but atmosphere too thick to strip completely. Stuck in worst of both worlds. Venus is like a knight who lost their shield but gained so much weight that arrows bounce off the fat. Not dead, but not exactly winning either. The final transformation timeline. Let's put this in perspective. 4 billion years ago, twin Earths, both blue, both wet. 3 billion years ago, Venus slightly warmer, still has oceans. 2.5 billion years ago, runaway greenhouse beginning. 2 billion years ago, oceans mostly gone. 1.5 billion years ago, surface temperature exceeds 300 degrees Fahrenheit. 1 billion years ago, full greenhouse hell established. 700 million years ago, global resurfacing event. Today, 900 degrees Fahrenheit, 92 bars, sulfuric acid rain, and backwards rotation. In the time it took Earth to go from single cells to Shakespeare, Venus went from paradise to purgatory. We write sonnets, Venus writes death certificates in sulfuric acid that evaporates before it hits the ground.
So, you want to visit Venus? Great choice. Let me tell you what you'll experience in the 127 minutes before you die. Yes, 127 minutes is the longest anything human-made has survived on Venus's surface. That was Venera 13 in 1982, and it was basically dead after an hour. Your descent into hell. Altitude, 250 kilometers. Welcome to Venus. You hit the first wisps of atmosphere. It's actually cold here, minus 40 degrees Fahrenheit. You think, this isn't so bad. You're wrong. Altitude, 100 kilometers, the sulfuric acid zone. Temperature, 32 degrees Fahrenheit. Clouds of concentrated sulfuric acid. Your spacecraft starts dissolving. Visibility, 0. You're in an acid fog from hell. The clouds are pretty from space though, all yellow and swirly, like vanilla pudding, if vanilla pudding was made of battery acid and hatred. Altitude, 50 kilometers, the temperate zone. Temperature, 75 degrees Fahrenheit, room temperature. Pressure, 1 bar, Earth-like. You could theoretically float here in a balloon for about 5 minutes before the acid eats through. This is Venus's habitable zone. Heavy air quotes. Altitude 30 kilometers, things get spicy. Temperature, 200 degrees Fahrenheit. Pressure, 5 bars. Winds, 200 miles per hour. Your parachute is fighting for its life. Electronics starting to fail. Altitude 10 kilometers, the cooker preheats. Temperature 400 degrees Fahrenheit. Pressure 30 bars. Atmosphere thick as water. Terminal velocity dropping. You're falling through hot soup. Altitude 0 kilometers, welcome to the surface. Temperature 864 degrees Fahrenheit. Pressure 92 bars. Visibility 1 kilometer on a good day. Everything is orange tinted. You have minutes to live. Congratulations, you've reached the surface of Venus. Please note the emergency exits. Just kidding, There are no exits. You're going to die here. What you'd see, briefly. The surface of Venus looks like the landscape, volcanic plains stretching to the horizon, everything bathed in orange light, no shadows, light scattered by thick atmosphere, rocks that look partially melted, no erosion features, no water to erode, maybe some fresh lava flows glowing. The sky, perpetual overcast, orange-yellow glow, no sun visible ever, no stars visible ever, lightning with no rain. The clouds 50 kilometers above might as well be space. It's like being at the bottom of an ocean made of CO2 if the ocean was 900 degrees and wanted you dead. The atmospheric pressure would crush your submarine. The temperature would melt your electronics. The chemistry would dissolve your equipment. Venus doesn't just kill visitors, it erases them. How Venus kills everything. Let's be specific about how you die on Venus. Option 1, crushed, most likely. 92 bars of pressure. Your body cavity collapses, lungs compressed to nothing, death in seconds. You become a human pancake. Option 2, cooked, if somehow pressure-proof. 864 degrees external temperature. Blood literally boils. Proteins denature instantly. You cook from the outside in. Well done in minutes. Option 3, poisoned, if somehow heat-proof too. Atmosphere is 96.5% CO2, immediate suffocation. Sulfuric acid burns everything. Heavy metals in the atmosphere, toxic in every possible way. Venus is an overachiever when it comes to killing. It's not satisfied with just one method of murder. It wants to crush you and cook you and poison you. It's the planetary equivalent of shooting someone who's already fallen off a cliff into a volcano. The geography of hell. Venus's surface is divided into 60% rolling plains, vast volcanic plains, relatively smooth, covered in lava flows, boring but deadly. 25% lowlands, below main radius, even hotter if possible, possibly ancient seabeds, extra dead. 15% highlands, tessera terrain, oldest surface, might have granite, slightly less hot, but still deadly. Venus has mountains taller than Everest. Maxwell Montes rises 11 kilometers above mean surface. You could climb it if you weren't dead. The summit is actually 80 degrees cooler than the base. Still 780 degrees though. Still dead. The volcanoes. Venus's acne problem. Venus has more volcanoes than any other planet. 1,600 major volcanoes. Hundreds of thousands of small ones. 167 volcanic features over 100 kilometers in diameter. Some might be currently active. Types of Venusine volcanoes. Shield volcanoes, like Hawaii but in hell. Pancake domes, flat volcanic features unique to Venus. Coronae, circular volcanic structures up to 2,500 kilometers in diameter. Arachnoids, spider-like volcanic features, because of course. Novae, star-shaped volcanic structures. Venus showing off. Earth has ring of fire. Venus has rings of fire, circles of fire, stars of fire, spiders of fire, and pancakes of fire. It's like Venus looked at Earth's volcanism and said, "That's cute, watch this." The lightning. Hell's light show. Venus has lightning. But because Venus can't do anything normal, no rain associated with it, possibly volcanic in origin, maybe from sulfuric acid clouds, maybe from atmospheric chemistry, we're not entirely sure. Venus has lightning without rain, thunder without storms, electrical discharge without water. It's like nature's laws took a vacation and forgot to come back.
Let's talk about Venus's atmosphere, which is less atmosphere and more an ocean of poison gas that happens to be gaseous. It's the thickest atmosphere of any rocky planet, and it's basically a chemistry set designed by someone who hates life. The composition, a recipe for hell. Venus's atmospheric ingredients: 96.5% carbon dioxide, the main killer, 3.5% nitrogen, the only normal thing, 150 ppm sulfur dioxide, forms sulfuric acid, 20 ppm water vapor, basically nothing, 17 ppm carbon monoxide, because why not, 12 ppm helium, trying to escape, 7 ppm neon, noble and useless, trace amounts of everything else toxic. It's like Venus looked at Earth's atmosphere and said, that's nice, but what if we made it poison, and then multiplied it by 93, and then heated it until it glows, and then added acid clouds for ambiance? The layers of hell, a vertical tour. The troposphere, 0 to 65 kilometers, where all the murder happens. Temperature decreases with altitude, like Earth, from 864 degrees Fahrenheit at surface to negative 40 degrees Fahrenheit at top. Contains those lovely sulfuric acid clouds. Pressure drops from crushing to merely lethal. The mesosphere, 65 to 120 kilometers. Temperature drops to negative 160 degrees Fahrenheit. Still mostly CO2. Solar UV starts breaking molecules apart, where hydrogen escapes to space. Venus slowly bleeding out its last water. The thermosphere, 120 to 300 kilometers, heated by solar radiation. Temperature rises to 300 degrees Fahrenheit on the day side, negative 280 degrees Fahrenheit on the night side. Atoms getting kicked into space, the escape zone for light elements. Venus's atmosphere is like a horrible layer cake where every layer is trying to kill you differently. The bottom crushes and cooks you, the middle dissolves you in acid, and the top freezes you while irradiating you. It's very thorough. The superrotation mystery, Venus's atmospheric rebellion. Here's something that breaks physics as we know it. Venus rotates once every 243 Earth days, but its atmosphere circles the planet every 4 days. The atmosphere is rotating 60 times faster than the planet. The wind speeds. At cloud tops, 360 kilometers an hour, 224 miles per hour. Middle atmosphere, 700 kilometers per hour, 435 miles per hour. Surface, 5 kilometers per hour, 3 miles per hour, because the air is so thick. Imagine if Earth's atmosphere just decided to leave, like it's spinning around the planet independent of the ground. You'd have permanent 200 mile per hour winds at ground level, cities would be sandblasted into nothing. Venus does this naturally. Scientists still don't fully understand why. Leading theories, solar heating at cloud tops drives it, atmospheric tides from the sun, some unknown mechanism we haven't figured out. Venus is just showing off. The acid rain that never lands. Venus has rain, sulfuric acid rain, but in the most Venus way possible, it never reaches the ground. The Virga phenomenon. Sulfuric acid forms in the clouds at 50 kilometers altitude. Acid droplets fall toward surface. Temperature increases as they fall. At about 25 kilometers altitude, the 570 degree Fahrenheit heat evaporates them. Vapor rises back up. Cycle repeats forever. Venus has been trying to rain for billions of years but keeps failing. It's like atmospheric blue balls. The clouds want to rain, they try to rain, but the surface is so hot the rain just gives up and evaporates. Even the weather has given up on Venus. The greenhouse effect, when keeping warm goes wrong. Let's talk numbers about how extreme Venus's greenhouse effect is. Solar energy received. Venus gets 2,600 watts per square meter at the top of the atmosphere, but reflects 75% due to clouds. Only 650 watts per square meter reaches the surface. Earth gets 1,360 watts per square meter, keeps more. The temperature paradox. Venus receives less solar energy added surface than Earth, yet surface is 864 degrees Fahrenheit versus Earth's 59 degrees average. The greenhouse effect adds 800 degrees to Venus. Earth's greenhouse effect adds only 60 degrees. Venus's atmosphere is so good at trapping heat that it's hotter than Mercury despite getting less sunlight at the surface. It's like wearing a winter coat in a sauna while standing farther from the heater than the guy in shorts who's freezing. Physics gave up trying to make sense. The phosphine controversy. Signs of life or signs of death? In 2020, scientists announced they found phosphine in Venus's atmosphere. On Earth, phosphine is only made by life, anaerobic bacteria. industrial processes, lightning in gas-giant atmospheres. Venus has none of these. Or does it? The excitement could be microbes in the cloud layer. Temperature and pressure at 50 kilometers altitude are Earth-like. Maybe life found a way. The reality check. Probably volcanic origin, or unknown chemistry, measurements disputed. Even if it's life, it lives in sulfuric acid clouds while being irradiated and living in a CO2 ocean. If that's life, I don't want to meet it. That's not first contact, that's first horror movie.
We need to talk about Venus's rotation, because it's wrong. Not just different, wrong. Every other planet in our solar system rotates the same direction they orbit. It's like a cosmic rule. Venus looked at that rule and said, "No thanks, I'll spin backwards while also spinning slower than I orbit because I'm quirky like that." The retrograde rebellion. Venus rotates clockwise when viewed from above the Sun's North Pole. Everyone else, counterclockwise. The numbers of wrong. Rotation period, 243 Earth days, backwards. Orbital period, 225 Earth days. Solar day, 117 Earth days, sunrise to sunrise. Axial tilt, 177.4 degrees, basically upside down. If you lived on Venus, you'd experience 2 sunrises per year. The sun would rise in the west, crawl across the sky for 2 months, then set in the east. Then you'd have 2 months of night. It's like Venus is deliberately trying to be difficult. Theory 1. Venus got punched in the face. The most popular explanation? Venus got hit hard. The giant impact hypothesis? Early in solar system history, massive object, planet-sized, hit Venus. Impact reversed its rotation. Also probably destroyed any moons. Explains lack of magnetic field too. Imagine getting hit so hard you start walking backwards forever. That's Venus. Some cosmic body the size of Mars probably said, "Yeet," and slammed into Venus so hard it's still confused 4 billion years later. Theory 2. The sun's gravitational bullying. Alternative theory, solar tides flipped Venus. The tidal friction model? Venus started rotating normally, but slowly. Thick atmosphere created atmospheric tides. The sun's gravity pulled on the atmospheric bulge. Friction between the atmosphere and surface gradually slowed the rotation to a stop, then reversed it. This is like the sun grabbing Venus's atmosphere and using it as a handle to manually reverse the planet's spin. Over billions of years. The ultimate long con, the slowest coup in history. The Earth-Venus dance, cosmic synchronization. Here's where it gets weird, as if it wasn't already. Venus shows the same side to Earth every time they're closest. Every 584 days, when Earth and Venus are at their closest approach, Venus has rotated exactly 5 times relative to the Sun. The creepy synchronization, not quite perfect, but close, suggests gravitational locking with Earth. But Earth is too small and far to cause this, unless it happened when orbits were different. Nobody really knows why. Venus is basically stalking Earth, making sure we always see the same side when we pass. It's like the planetary equivalent of that person who always happens to be at the coffee shop when you are. Coincidence? Gravitational harassment? We don't know. The day that lasts forever. Let's talk about what this backward, slow rotation means for the surface. The eternal day. 58 Earth days of sunrise, 58 Earth days of sunset. The sun moves backwards across the sky. Shadows would move backwards if there were any. Noon lasts for weeks. The eternal night. 58 Earth days of darkness. No temperature change. Greenhouse effect. No stars visible through the atmosphere. Complete darkness except for volcano glow. Maybe some aurora from solar wind. Imagine a sunrise that takes 2 months. You could watch the sun rise at walking speed, except you can't because you're dead, and the sun isn't visible through the clouds, and the surface is 900 degrees. Venus ruins everything, even its own poetry. The missing moon's mystery. Venus has no moons. 0, none. This is weird because Mercury has none, too close to the sun. Earth has 1, big one. Mars has 2 captured asteroids. Venus has nothing. Where did Venus's moons go? Never had any? Unlikely. Destroyed in the giant impact? Spiraled into the planet due to tides? Ejected by Earth's gravity? Eaten by the sun? Every planet deserves a moon. Even Mars got 2 crappy asteroids. But Venus? Nothing. It's the lonely cat lady of planets, except instead of cats, it has sulfuric acid clouds, and instead of loneliness, it has crushing atmospheric pressure. Venus is still slowing down. Venus's rotation is getting even slower, loses about 6.5 minutes per Venus day per million years. In a billion years, might be tidally locked to the sun. One side permanent day, one side permanent night. The day side becomes even more hellish. The night side is merely extremely hot instead of insanely hot. It's lose-lose.
We need to talk about the Soviet Union's relationship with Venus. Between 1961 and 1984, they sent 16 Venera missions to Venus. Most died horribly. It was like they were personally offended by Venus's existence and decided to throw spacecraft at it until it surrendered. Spoiler, Venus never surrendered. The Death Toll, a memorial for fallen robots. Venera 1, 1961, lost contact, probably flew past Venus, alone and forgotten. Venera 2, 1965, lost contact just before Venus. So close, yet so dead. Venera 3, 1965, first human object to hit another planet, also immediately destroyed. USSR said, "We meant to do that." Venera 4, 1967, thought it landed, actually crushed at 25 kilometers altitude. Venus said, "You're not even at the surface yet, comrade." Venera 5 and 6, 1969, both crushed during descent. Venus going for a double kill. The Soviets kept sending probes like Venus was a piñata and they really wanted the candy inside. Except the candy was scientific data and the piñata was filled with sulfuric acid and crushing pressure. Venera 7, first contact with Hell. December 15th, 1970. Venera 7 becomes the first spacecraft to successfully land on another planet and transmit data. The 23-minute miracle. Landed at 35 miles per hour, parachute failed, tumbled on its side, transmitted temperature 887 degrees Fahrenheit, transmitted pressure 90 atmospheres, then died. For 23 minutes, humanity had a phone call with Hell. The message was basically, hot, pressure, dying, goodbye. It was the shortest and most depressing interplanetary communication ever. The first pictures, Venus's photo shoot. Venera 9 and 10 sent the first images from Venus's surface. What we expected? Darkness, maybe some rocks. What we got? Clear visibility, 1 kilometer, distinct shadows, sharp rocks everywhere, flat volcanic plains, orange-tinted hellscape. Venus was surprisingly photogenic for a death world. Like finding out your serial killer neighbor takes really nice landscape photos. Doesn't make them less murderous, just more artistic about it. Venera 13, the champion of survival. March 1st, 1982, Venera 13 lands and survives for 127 minutes, still the record. What it accomplished? First color photos of the surface, drilled into the surface, analyzed soil samples, recorded sound on Venus, survived over 2 hours. The ironic tragedy? The lens cap ejected perfectly right where the soil analyzer was supposed to sample. Venera 13 traveled 200 million miles to analyze its own lens cap. It's the most Soviet thing ever. Venus was probably laughing. The sounds of hell. Venus's voice. Venera 13 and 14 recorded sound on Venus, the first sounds from another planet's surface. What Venus sounds like? Constant low rumbling, wind, but very muffled due to thick atmosphere, thunder, maybe, the sound of the lander dying. Venus sounds exactly like you'd expect hell to sound like, ominous, rumbling, and wrong. It's the planetary equivalent of death metal played through soup.
Scientists cleaned up the audio, and it still sounds like somewhere you don't want to be. The Vega balloons, flying through acid. 1985, the Soviets tried something different. Balloons. The Vega missions dropped balloons into Venus' atmosphere, floated at 54 kilometers altitude, where temperature is only 100 degrees Fahrenheit, pressure is Earth-like, lasted 46 hours before batteries died. For 2 days, we had weather balloons in Venus's atmosphere floating through sulfuric acid clouds at hurricane speeds. They reported back, still hell, but flying hell. It was the longest anything human-made survived at Venus, because they cheated and didn't land. Meanwhile, America will go to Mars instead. While the Soviets were throwing themselves at Venus, NASA took a different approach. Mariner 2, 1962, flew by, took measurements, said nope. Mariner 7, 1967, another flyby, confirmed the nope. Mariner 10, 1974, used Venus for gravity assist, didn't stop. Pioneer Venus, 1978, orbiter and atmospheric probes, still didn't land. Magellan, 1990, mapped the surface with radar from safe orbit. America looked at Venus, looked at the Soviet casualties, and decided we'll take the cold dead planet instead of the hot dead planet. Mars might be trying to kill us, but at least it's not trying as hard as Venus. The modern era, we're still trying. Current and planned Venus missions. Akatsuki, Japan, 2015, currently orbiting, studying atmosphere. Parker Solar Probe, USA, using Venus for gravity assists, taking pics. Bepi Colombo, Europe and Japan, also using Venus, also scared to land. Da Vinci Plus, USA, 2029, will drop a probe through atmosphere. Envision, Europe, 2031, will study geology from orbit. Notice how most modern missions don't even try to land? We've collectively decided that orbiting Venus is dangerous enough. It's like we all agreed, let's study the serial killer from across the street with binoculars instead of knocking on their door.
All right, time for the existential crisis portion of our program. We've spent minutes talking about how Venus became hell. Now let's talk about the uncomfortable truth. Earth is on the same trajectory. We're just earlier in the process. The runaway greenhouse. Could it happen here? Short answer, yes. Long answer, yes, but probably not for a billion years unless we really screw up. Earth's safety margins. Current average temperature, 59 degrees Fahrenheit. Temperature for runaway greenhouse, 185 degrees Fahrenheit. Current CO2, 420 ppm. Venus's CO2, 965,000 ppm. We have time, probably. Earth is protected by what scientists call the carbonate-silicate cycle. CO2 dissolves in rain, forms carbonic acid, weathers rocks, gets locked in carbonates. Venus lost this when it lost water. We still have it, for now. The moist greenhouse, the beginning of the end. Before runaway greenhouse, Earth will experience moist greenhouse. The stages. Temperature rises to about 150 degrees Fahrenheit average. Water vapor increases in the stratosphere. UV breaks apart water molecules. Hydrogen escapes to space. Oceans slowly evaporate. Process accelerates. Timeline without human help. 500 million years, uncomfortable. 1 billion years, moist greenhouse begins. 1.5 billion years, mostly gone. 2 billion years, full Venus conditions. The good news is we have 1 billion years. The bad news is we're speed running this process. It's like we looked at Venus and said, that looks fun, let's try it, but faster. Humanity's contribution, helping Earth become Venus. What we're doing to help Earth become Venus: current CO2 emissions, 37 billion tons per year, increasing 2% annually. Atmospheric CO2 rising 2.5 ppm per year, fastest increase in 66 million years. The feedback loops we're triggering. Melting permafrost releases methane. Less ice means less reflection. Warmer oceans hold less CO2. Forest fires release stored carbon. Each feeds the others. We're basically giving Earth a fever and then wrapping it in blankets while force-feeding it greenhouse gases. It's like we're Venus's intern, learning how to destroy a planet but starting with baby steps. The tipping points, when Earth says enough. climate scientists have identified several points of no return. Already passed? Arctic summer ice loss, West Antarctic ice sheet destabilization, coral reef die-offs, permafrost thaw initiation. Coming soon? Amazon rainforest dieback 2 to 3 degrees Celsius warming, Greenland ice sheet collapse 1.5 to 2 degrees Celsius warming, West African monsoon shift 3 to 5 degrees Celsius warming, complete Arctic ice loss 2 to 3 degrees Celsius warming. We're playing planetary Jenga, pulling out blocks and seeing how many we can remove before everything collapses. Venus already played this game. Spoiler, Venus lost. The desperate solutions: try not to become Venus. Humanity's plans to avoid Venusification. The reasonable ideas: stop burning fossil fuels, LOL. Plant trees, they keep burning. Carbon capture, expensive and slow. Renewable energy, too little, too late. The desperate ideas: solar radiation management, space mirrors, stratospheric aerosol injection, artificial volcanoes, ocean fertilization. What could go wrong? My favorite is the space mirrors. Let's put giant mirrors in space to reflect sunlight. Because if there's one thing humans are good at, it's massive space infrastructure projects that require global cooperation. We can't even agree on pizza toppings. The Venus speedrun. How fast could we do it? If humanity really tried to turn Earth into Venus, the optimistic scenario: we stop now. 2100 plus 2 degrees, uncomfortable but manageable. 2200 plus 3 degrees, major problems. 2500 plus 5 degrees, civilization collapses. 3000, Earth recovers slowly. The business as usual scenario: 2100 plus 4 degrees, coastal cities underwater. 2200 plus 8 degrees. 2500 plus 15 degrees, most land uninhabitable. 3000, runaway effects begin. The worst case, all feedbacks trigger: 2100 plus 6 degrees, societal collapse. 2200 plus 12 degrees, oceans acidified. 2300 plus 20 degrees, water vapor feedback. 2500, moist greenhouse begins. 5000, Venus 2.0. The good news is, even in the worst case, it takes thousands of years to become Venus. The bad news is, we're already making Earth uninhabitable for humans way before that. We don't need to become Venus to destroy civilization. We just need to become slightly worse Earth. Why Earth isn't Venus yet? Our safety features. What's protecting Earth from immediate Venusification? Distance from Sun, 28% farther than Venus, receives 50% less solar radiation. Just inside the habitable zone, but zone is moving outward as the Sun ages. Magnetic field protects atmosphere from solar wind. Venus lost its magnetic field. Earth's is weakening but still strong, probably good for millions of years. Plate tectonics recycles carbon into the mantle, releases pressure gradually. Venus doesn't have this, keeps Earth's thermostat working. Life. Photosynthesis removes CO2, creates oxygen, moderates temperature, unless we kill it all. Earth has safety features Venus lost. We have airbags, seatbelts, and brakes. We're just currently cutting the brake lines while accelerating toward a cliff, but hey, the airbags still work.
Okay, let's talk about the ultimate human hubris: terraforming Venus, making hell habitable, turning Satan's vacation home into a garden paradise. It's the planetary equivalent of renovating a house that's currently on fire, underwater, and full of bears. The challenge: everything is wrong. To make Venus habitable, we need to fix temperature, drop it 800 degrees Fahrenheit. Pressure, reduce by 91 atmospheres. Atmosphere, remove 99% of CO2. Rotation, speed it up 243 times. Water, add about 1 billion cubic kilometers. Magnetic field, create one somehow. Sulfuric acid, neutralize it all. That's like trying to turn a nuclear explosion into a birthday party while it's still exploding. But sure, humans, let's discuss your adorable plans. Option 1, the solar shade, blocking the sun. The Paul Birch plan, solar shade at L1 point, blocks all sunlight to Venus. Atmosphere freezes and falls as dry ice. Pressure drops to manageable levels, then removes CO2 somehow. Problems: shade needs to be bigger than Venus.
would mass billions of tons, needs constant adjustment. One failure equals Venus heats up again. Where do you put the frozen CO2? This is like solving obesity by never eating again. Technically works. Practically impossible, definitely going to cause other problems. Also, a frozen Venus is still dead, just differently dead. Option 2. Atmospheric stripping. Blow it away entirely. Methods proposed. Mass drivers launching atmosphere to space. Solar wind enhancement to strip it away. Artificial magnetosphere to direct removal. Nuclear explosions to blow it off. Seriously. The math. Need to remove 4.8 times 10 to the 20th kilograms of gas. Energy required 10 to the 31st joules. That's 100 million years of Earth's total energy. We're talking about manually removing an atmosphere that weighs more than all of Earth's oceans, using more energy than humanity has produced in its entire existence to fix a planet we can barely land on. Sure, totally reasonable. Option 3. Biological warfare. Attack with life. Carl Sagan's 1961 idea, seed the clouds with algae. The plan, genetically engineered bacteria or algae, thrives in sulfuric acid clouds, converts CO2 to oxygen, dies and falls as carbon rain. Repeat for centuries. Why it won't work? Venus has no water for photosynthesis. Surface temperature destroys organics. No way to sequester the carbon. Bacteria would need impossible chemistry. Even if it worked, it takes millions of years. Let's throw bacteria at the problem is such a human solution. It's like trying to clean your house by releasing a billion cockroaches and hoping they eat the dirt. Technically, something would happen, but not what you wanted. Option 4. Comet bombardment. Add water violently. The insane plan. Find suitable comets in the outer solar system. Redirect them to Venus, somehow. Each comet adds water. 100 plus comets needed. Impact energy helps blow off the atmosphere. The problems. Each impact releases catastrophic energy, would increase Venus's temperature initially, might trigger even more volcanism, takes thousands of years minimum. Who controls the comets? This is basically trying to put out a fire by dropping frozen lakes on it from orbit, while the house is full of dynamite and the dynamite is already exploding. But sure, what could go wrong with hurling comets at planets? Option 5. Spin it up. Make Venus dizzy. The idea? Speed up Venus's rotation using asteroid impacts. The angular momentum plan. Hit Venus with asteroids at specific angles. Each impact adds rotational energy. Need thousands of precisely aimed impacts. Eventually get Earth-like day-night cycle. Why this is insane? Need to increase rotation 243 times? Each impact causes global devastation? Timing needs to be perfect. One wrong hit undoes centuries of work. Still doesn't fix the atmosphere. We're literally talking about playing cosmic billiards with a planet. Just hit it at the right angle a few thousand times with mountain-sized rocks. This is peak human confidence. We can't parallel park, but sure, let's parallel park asteroids into a planet. The time problem. Longer than civilization. Even the most optimistic terraforming plans take minimum timescales: solar shade deployment, 100 years. Atmosphere freezing, 200 years. CO2 removal, 500 years. Adding water, 1,000 years. Biological seeding, 10,000 years. Full terraforming, 50,000 plus years. Human civilization is 10,000 years old. We're talking about a project that takes 5 times longer than we've existed. The pyramids would be prehistoric artifacts by the time Venus became habitable. We can't even agree on infrastructure projects that take 5 years. The cost, more than Earth's GDP forever. Conservative estimates for terraforming Venus. Financial cost, 100 quadrillion minimum. That's 1,000 times global GDP. Every human pays $10 million for thousands of years with no return on investment for millennia. Resource cost, all of Earth's industrial capacity, strip mine entire asteroids, massive space infrastructure, millions of people in space, multiple backup Earths worth of resources. For the cost of terraforming Venus, we could fix Earth's climate 10,000 times over, build cities on Mars, the Moon, and Europa, give everyone their own spacecraft, solve every problem on Earth, still have money left over to burn, but no, let's fix the murder planet.
So here we are.
minutes into the story of how Earth's twin became the solar system's most successful planetary suicide. We've covered the science, the death, the warnings, and humanity's adorable plans to fix the unfixable. What have we learned? The lesson of Venus: planets can die. Venus teaches us that habitability is fragile. Climate has tipping points. Runaway effects are real. Once broken, planets don't heal. The universe doesn't care. Venus isn't just a cautionary tale. It's proof that planets can fail, that worlds can die, that the difference between paradise and hell is a few degrees and some bad luck. Earth's choice. Which twin do we become? We stand at a crossroads. Path 1, the Venus route. Keep pumping out CO2. Trigger feedback loops. Ignore the warnings. Hope technology saves us. Become Venus Junior. Path 2, the Earth route. Recognize the danger. Act before tipping points. Preserve our water cycle. Maintain habitability. Don't become Venus. The irony is that Venus is literally showing us our future. It's hanging in our sky, visible to the naked eye, screaming, "This is what happens!" in frequencies of infrared radiation and sulfuric acid clouds. And we're like, pretty evening star. The beauty of the killer. Despite everything, Venus is beautiful. Brightest natural object after sun and moon. Gorgeous crescent phases. Stunning at sunrise and sunset. Named after the goddess of love. Inspired poetry for millennia. There's something poetic about Venus being both beautiful and deadly. It's the cosmic femme fatale, the planetary siren song. It draws us in with its brilliance while hiding an atmosphere that would crush us, cook us, and dissolve us simultaneously. Why we can't stop studying Venus. We keep going back to Venus because it's Earth's future if we fail. It might have had life once. It teaches us about planetary evolution. It's close and accessible. We're curious idiots who poke dangerous things. Narrator. Every Venus mission is basically humanity saying, "I know it keeps killing our robots, but what if we send another one?" It's the planetary science equivalent of a toxic relationship. Venus hurts us, we keep going back, Venus hurts us again. Venus and Earth started the same materials, same neighborhood, same potential. One became a garden of life. One became hell itself. The difference? A little more sunlight, a little less water, a magnetic field that failed, plate tectonics that stopped. Small differences that cascaded into complete transformation. Earth isn't special because we're better. We're special because we're luckier. Venus rolled snake eyes in the cosmic casino. Earth rolled 7. But the dice are still rolling. Tonight, go outside at sunset. Look west, find Venus, the brightest star in the twilight sky. Look at it. Really look at it. You're seeing Earth's twin, Earth's warning, Earth's possible future. That brilliant point of light is a 900-degree, sulfuric acid-wrapped, backward-spinning hell world that was once potentially habitable. It's beautiful from here. It's death up close. It's the ultimate reminder that planets can fail, that habitability is temporary, that the universe owes us nothing. Venus chose violence. Or violence chose Venus. Either way, it's dead.